Hello and welcome to Our Stories and Ourselves, a podcast about how our minds make stories and stories make us. My name is Kirsty, and in this show, I talk about the stories we tell ourselves about the world, the stories we tell ourselves about each other, and about how the way we think shapes these stories and shapes us. This episode, I'm going to talk about the replication crisis in psychology and how the stories we tell about research and the way we tell them have played a role. I'll go through a few examples and do a bit of a deep dive into the research around self-fulfilling prophecies. This one in particular got my attention as, when it comes down to it, prophecies are stories we tell ourselves about ourselves, and about each other. Ugh, I didn't write that sentence for search engine optimization, but it reads like I did. This episode has been a while coming, as I dove deep into the references again. I think it's 27 this time. They're all on my website, ourstoriesandourselves.com, if you want to know more about anything I talk about today. Anyway, the replication crisis is the name for findings across the past 15 or so years that a lot of research studies can't be replicated. This occurs in a bunch of fields, including economics, but psychology is the one most familiar to me, so it's the one I'm focusing on today. To make sure we're all on the same page, replication refers to the process of repeating a study or experiment. Basically, doing the same thing over again, perhaps with a broader population. The aim is to verify the effects seen in the first study, or to generalize the findings across new models or populations. So it's not just about whether the same thing happens if you run the same experiment, although that's part of it. It's also about, does it happen with anyone other than first-year psychology students, which is the population of convenience for research studies? This lack of replication or replicability is not ideal, to say the least. However, when I started digging into it, there is more nuance than a replication crisis in psychology headline would lead you to believe. Some of it is about the studies. Some of it is about which ones are published, and some of it is outright fraud. But more on that in a bit. Let's start with the stories we tell about research findings. A big thing in psychology research when I was studying, in fact, one that we looked at in one of my third-year group research projects, was something called social priming. Basically the concept that if you make an idea forefront in someone's mind, they will act in a way that's consistent with that idea. The main research we studied was a task that brought up a lot of words associated with age and being old. The idea was that this may prime the concept of being old and lead a person to walk more slowly. And this was what the researchers found. It was simultaneously a big deal, the idea that something as simple as reading a list of words could change behaviour, but something that didn't seem unreasonable when you heard about it. People may walk a bit slower when thinking about being old, I guess. However, it turns out that that effect may not actually be real. Attempts to replicate it have been unsuccessful. As an aside, if I'm remembering something I did nearly 20 years ago correctly, ouch, we didn't find an effect either. It may have been, as we said at the time, due to a small sample size, but I'm wondering now if it is because there was no effect to find. It's also worth noting that this is different to cognitive priming. This is where seeing a word on a page makes it easier to recognize in a following list. So that if you see the word green, then it's easier to pick out of a list immediately after that than if you just hear the word. It's also not a great leap from there to social priming. So because cognitive priming does have an evidence base, I think it's a reasonable step that people took from that to social priming. Anyway, the original study found an interesting effect. It got published in a journal, and headlines and textbooks ran with it. However, studies that don't find an effect have a harder time. This is known as publication bias. New, exciting findings are more likely to be published. And I get it. It's just less interesting to find out something didn't happen. So even when researchers try and replicate a finding, they may struggle to get the information out there if they do get a different result. In addition, some journals even had, or maybe have, explicit policies not to publish replications. They will only publish novel findings. Bluntly, that seems ridiculous to me. We're taught that the scientific method always involves questioning and testing findings, trying to do things repeatedly and seeing if we get the same results. To not publish replications, especially if the findings are different, just goes against that whole concept, to my mind. For a long time, researchers did respond to this by replicating and extending previous studies. So basically doing the same thing, but adding a novel element. And this did allow a fair amount of replication to be done and published, but it's still not ideal. Thankfully, the reluctance to publish replication is now changing, at least in some journals. In fact, the Royal Society Open Science Journal is committed to publishing replication studies. This is a good start, but it will need ongoing work across psychology and the other fields where this is an issue to make sure that if findings aren't replicated, the information is as widely spread as the original study. The drive for publication and the tendency of journals to lean towards interesting findings has also led to other issues. It means there's an incentive for researchers to focus on finding and reporting interesting things, which is also exacerbated by limited word counts in many journals. It makes it even easier to mention the things that were significant and ignore those that weren't. Selective reporting, in other words. It doesn't mean the reported difference isn't there, just that it's only part of the picture. There should definitely be more acceptance of mixed results in journal articles. If anything, I think that it can make it more interesting. And we've got so much more room now that stuff can be published online. For example, if an intervention reduces scores on a depression scale but not on an anxiety scale, that's still an interesting finding. But both should be reported, not just the depression scale. Of course, it's one thing if you test an intervention on a depression scale and an anxiety scale and it only has an effect on one of them. It's quite something else to throw a whole bunch of statistical tests at the wall and see what sticks. This is one of the questionable research practices that has also contributed to the replication crisis. Sometimes called p-hacking or data dredging, it's running multiple statistical tests on a single data set and then only reporting the significance findings, potentially even generating your hypothesis once you've got them. It's kind of like cherry-picking facts in an argument. So on the upside, researchers are working on ways to reduce the risk of these practices occurring. One of them is something called pre-registration. It involves registering a research design and plan before starting the work. While this gives less flexibility, it does make sure that people don't change their hypothesis after the fact or throw in a bunch of unplanned statistical tests. Or at least if they do, they have to do it transparently and caveat the findings accordingly. It's also helpful for the publication bias I mentioned before. Some journals are now committing to publishing the findings of any study that they publish the pre-registration for. This reduces the risk of the less interesting findings, or those which don't find an effect, ending up on a cutting room floor. However, the issues don't stop there. As the replication crisis was being uncovered, several prominent social psychologists were found to have perpetrated active research misconduct and even to have fabricated data. This is not just digging through the data for a significant finding. This is flat-out fraud. Now, again, some of the open science principles would help here. Publishing research plans, data, and better peer scrutiny, along with the encouragement and publication of replication studies, especially by other researchers, would at least make fraud harder to hide. And all of these principles have made a difference. Research, especially in psychology, but also more generally, is stronger now than it was in 2011 because of the response to the replication crisis. Some of this will take time. Open science wasn't something we covered much when I studied psychology, if at all, and it will take a while to become embedded. It also needs the input of all of the media that report on psychology findings, as well as the discipline itself, and that's definitely a lot more tricky. But something struck me as I was reading through all of this. The story of the replication crisis isn't that science is failing. It's the story of several related but different problems being grouped together under one heading, lumped together as one crisis, when there is more to it than that. They are related stories, and the potential solutions also overlap, so it makes sense to group them together. But it's also worth acknowledging that nuance. Out-and-out fraud is different from p-hacking, which is different from being unable to get a replication study published. But they have all been badged as the replication crisis. I think this risks people casting more doubt on research findings than is reasonable, and makes it hard to pick up the pieces. As with everything, there is nuance here, and we risk losing sight of that when talking about the replication crisis as one big thing. Another element I think is worth talking about is the interpretation of the findings, rather than the exact probability of the difference being significant. No matter how precise and scientific the research is, there's always going to be some amount of interpretation, and then that interpretation guides the next steps of the research. To go back to the ash line experiments I talked about in episode 3, the finding that people will agree with a group conclusion, even when it's obviously wrong, definitely occurs. This is one that has been replicated again and again. However, as I mentioned at the time, not everyone does it. Some of the follow-up studies have focused on whether there are circumstances where people are less likely or more likely to agree. They've also looked at the characteristics of those who do and don't agree. So I think there's also something to be said for focusing on gathering data about an underlying theory and mechanism rather than a direct replication, or just doing a direct replication of a specific task. The ash line experiments have been repeated, but there have also been a lot of other studies on how beliefs spread through groups. People are more likely to believe something if they are told 80% of other people believe it. This is an important issue in our society, especially today when misinformation is rife. Most people do believe that trans rights are human rights. But if the noisy minority keeps saying something different, more people may come to believe it, because they believe it's what most people believe, rather than it being what a small group of bigots believes. On the flip side, the more people who say they support trans rights, the more people will realise they're not in the minority in that belief. I think this relates to the conversation I had with Kelly in episode 6, that while news stations may have to be objective, the way that they do that, I think, currently is flawed. News stations have to be balanced, but it doesn't necessarily mean giving both sides equal weight. If 95% of scientists say the evidence supports human-driven climate change, then they should get 95% of the media coverage. You don't have to completely ignore the other 5% of scientists. Just make it clear that their reasoning is not supported by most, and maximum give them a little airtime. Both this and some of the early examples emphasize that how findings are reported, both in the scientific literature and more widely, matters when we're trying to understand the impact of a study. Take, for example, the self-refilling bowl of soup experiment. If you're not familiar with it, it was a study where participants were given bowls of soup and told to eat as much as they wanted. One group would have the bowl refilled manually by an experimenter whenever they reached the bottom. The other had a self-refilling bowl, so it seemed basically bottomless, and they weren't aware that the bowl was refilling. In the initial experiment, researchers found a substantial difference between the two groups. Those whose bowls were being filled without them knowing ate more soup than those who had the bowl refilled manually and had visual cues to help them know how much they had eaten. It's an interesting finding and suggests that if people want to manage how much they eat, to put a portion on a plate and put the rest of the food away. So definitely not like me cooking a pizza, saying I'll save half for tomorrow and then demolishing it all mindlessly while watching TV because the plate's next to me. But enough about me. Subsequently, the author of the original study was found to have participated in some questionable research practices, and several of their papers were pulled. I didn't see any details of exactly what happened in the article I read, but when researchers replicated the soup study, they had a similar finding. A smaller effect size, but a similar finding. So you may be wondering what an effect size is. Let's go on a quick side quest. An effect size is what it sounds like. It's the size of an effect. So for the soup study, it's the difference in the average amount of soup eaten between the groups. I don't know what it was in that study, and this episode is already so late, I'm not going to go down another rabbit hole. But let's say it's half a cup of soup. Half a cup of soup can add up to a lot of calories over a month if you eat soup frequently. And it was a smaller effect size than the previous study, which let's say that was a whole cup of soup. But half a cup of soup is still meaningful. If the effect sizes had been a teaspoon of soup and half a teaspoon of soup, neither would have meant very much at all. Effect sizes are important when we look at how much the difference we are looking at actually matters. It's not always as easy to understand as a cup of soup, but there are mathematical ways to measure the size of an effect. And this is something that has gained more attention as a result of the replication crisis. There is an expectation to report effect size as well as statistical significance, which helps us to understand the context of a finding. For example, a sleep intervention might find a statistically significant difference between the control group and the experimental group, but if that translates to 10 minutes of sleep, it may not actually be meaningful for the participants. And I think this is important to talk about both in the context of the replication crisis and more generally, and especially if you're me and doing pop science, pop psychology podcasts. But now, as I trailed in the intro, I want to talk about self-fulfilling prophecies. You're probably familiar with the term. It's the idea that people will act in ways consistent with what they believe, which leads to that belief being supported or fulfilled. It's used in lots of different ways in lots of different fields. And of course, that is where problems creep in. I first learned about the idea in relation to teachers and their expectations of students. There was a famous study which first identified it in the 1960s. If you're not familiar with it, let me set the scene. A school normally sorts their students into 3 streams: the high achievers, the average group, and those that need a bit more help. The idea is that no one gets frustrated because things are moving too fast or too slowly. But there's a worry that by sorting the kids like this, it sets an expectation. The teachers treat the kids like they belong in that stream, and the kids live up to it. So some researchers set out to test this idea. They didn't want to do anything that could be detrimental to the students, so they didn't demote any students to a different class. Instead, they told teachers that, based on a test they'd done at the start of the year, specific students in their class were what they called bloomers. Kids that, based on test scores, were likely to perform better than otherwise expected across the year. In reality, the label of bloomer was randomly assigned. There was nothing different about these kids, they just wanted the teachers to think that there was. Then they sat back to see what would happen. When they tested the kids again at the end of the year, their hypothesis was confirmed. When teachers expected kids to perform better, the kids did. So, if we expect more of kids, they will do better. And on the potentially more damaging flip side, it suggests that if we don't expect much of them, they won't do as much. In other words, the stories that teachers tell themselves about the student affect the way that they teach the student, and then the student responds to those expectations and that teaching. It becomes a self-fulfilling prophecy. But wait. This episode is about questionable research and the replication crisis. So does this hold up? I'll get to that in a second, but I did notice a couple of interesting things while reading up on the study that I didn't remember learning about back at uni. There was a statistically significant effect in 1st and 2nd grade, but not for 3rd to 6th grades. The experimenters do note this, to their credit. They report all of their findings, and it does help when you've got a whole book to do it in. And there is a significant effect when all the grades are grouped together in the analysis. However, it was interesting that, again, the headline I remember, and which tends to get reported, actually has a bunch of caveats. Part of the issue is how the findings are disseminated and talked about more broadly. But do they replicate at all? I'm going to quote directly from a Psychology Today article by Dr. Lee Jussum. Teacher expectations produce self-fulfilling prophecies in the classroom, but these effects tend to be weak, fragile, and fleeting. Few other researchers would describe them this way. But when you look at the actual findings, this is pretty much what almost everyone has actually found. End quote. So that feeds into a few things I've talked about, because that's also hinting that maybe the researchers have interpreted the findings in a slightly different way to Dr. Jussum. Interestingly, that same article did mention that students' self-perception can have a bigger effect on their performance than the teacher's perceptions of the student, but I'll come back to that in a minute. Dr. Jussum's quote takes us back to effect size. The increase in a scores on a test might be statistically significant, but they may not actually mean much when it comes to the student's achievements. And the research also suggests there are a lot of factors which affect students' performance. The expectations of the teachers is only one small part of it. A class getting, 5 points higher on a maths test consistently looks good, but is it actually going to affect things longer down the line? It's also worth noting that the initial study only involved 6 teachers, and it's reasonable to ask if different teachers react differently to the information that their students may bloom over the course of a year. Some may have been better at having reasonable expectations of all their students, or may just not have believed the researchers that some students would improve more than expected over the year. Anyway, all of these studies focus on how what a teacher thinks about a student affects that student. How about the expectations we have of ourselves or of other things? The simplest one is the placebo effect. Thinking you're getting the medicine in itself helps you feel better. So it's a very simple self-fulfilling prophecy. Other ones that have been studies include predictions about markets and banks, which can have a self-fulfilling effect. I read an interesting, if somewhat hard to follow, economics paper which made the case that a run on some US life insurance companies back in 2007 was partly due to self-fulfilling prophecy. Now, I didn't fully follow the maths, but my understanding is the belief that it would be hard to get the money that had been invested in these companies out led to a situation where it was, in fact, hard to get the money out due to the number of people doing so. However, if the withdrawals had continued at the normal rate for those companies, it wouldn't have been a problem. A simulated task had a similar finding that people's predictions about the economy changed their behaviour when buying virtual stocks. I also found an interesting paper about people downloading music online that suggests that self-fulfilling prophecy is a factor in which songs become popular. The researchers offered people the chance to download songs after listening to and rating them. The songs they chose to listen to and rate were affected by which ones they were told had the most previous downloads. Although, interestingly, there were some people who actively sought out the least downloaded songs. There could be several reasons for that, but given it was music, I think it was probably hipsters wanting to listen to songs before they're popular. Anyway, while the perceived popularity of the songs did affect the behaviour of the participants, when that perceived popularity had been manipulated, it also led to fewer downloads overall. So when people were led to believe that the least popular songs had been downloaded the most, those people just engaged less with the whole project. So any seller that floods the reviews with fake 5-star ratings, beware. You could be shooting yourself in the foot. I guess that means I should be endorsing honest ratings for my show as well. 4 stars. 4 stars is okay, right? Anyway, another study, which I don't have time to go into a great deal, found that parental involvement in a substance use prevention program was more effective if the parents thought that their involvement would be helpful. There's some pretzels going on in that one, but I think you get the idea. It's interesting that these studies where they've found effects of a self-fulfilling prophecy, these are all things where people don't know much about the situation or they don't have much external evidence about it, such as the risks in the market or how helpful parental involvement in a prevention program is. Or in some of the studies, if information has been deliberately withheld or distorted, such as the case of the songs and the placebo effect. Then, if you don't have other data to go on, the self-fulfilling prophecy effect is present. However, when there is other information available, it seems to have less of an effect. For example, the wider findings about self-fulfilling prophecies in teachers. There's a small effect there, but most teachers have fairly accurate assessments of their students. And it makes sense. They gather a lot of evidence across the school year and about how the student is performing, so they've got something to base that assessment on. Now, I haven't done an exhaustive lit review on this, so take it with a pinch of salt, but that's my kind of hypothesis so far from what I've read. On the other hand, as I mentioned, students' self-perceptions can have a detrimental effect on their performance. So what's that about? Surely they have more information about themselves than anyone else. My personal theory is there are several things at play here. I mean, firstly, assuming I'm bad at something is kind of demotivating. It also means I'm probably looking out for things that go wrong and giving that evidence extra weight. So, confirmation bias, basically. It's also, if I'm expecting to do badly at something, I may be less likely to try or to persist at something that takes practice. And so once again, it's a complex, nuanced story. And we're not always great at self-assessment. To loop back to the replication crisis, to gain a deeper understanding of self-fulfilling prophecies and other phenomena, we need to understand both when there is an effect and when there isn't, what size the effect is, and how it fits into the wider field of study. We also need to look at how we interpret the findings and where we can dig more into the differences between individual responses, as well as between groups. Open science strategies like pre-registration and sharing research protocols and data will also help, as will, I think, not overgeneralizing from one study to the whole world. We need to get better at telling pop science stories that include the nuance of the original research. Oh look, there's that word again. It is something I do try to do with the podcast, but I don't always hit the mark. It's not peer-reviewed or pre-registered after all. So do reach out if I've got something wrong or there's something you want to chat about. As I said earlier, the website with all my references is ourstoriesandourselves.com, which is also linked in the show notes. If you have thoughts, drop me an email at ourstoriesandourselves@gmail.com or on Blue Sky at ourstories.bluesky.social. You can also join the Patreon at the free tier and access the chats there. They're pretty quiet, but who knows, maybe they'll pick up. And feed the algorithm with likes, reviews, and subscriptions, or just tell your friends. Thank you as always for listening, and until next time, write your own story.